Good evening, everyone. A warm welcome to this month's CERCA expert talk on climate change, air pollution nexus, to be delivered by Professor Vikram Singh of Chemical Engineering Department at IIT Delhi. I'm also conveying our apologies for not having Mr. Duggal with us today due to his health problem. He is a bit unwell, so he has expressed his regrets for not attending this seminar today. We are very thankful to Professor Vikram for selecting a very relevant topic for his talk, as we have not really started talking about how air pollution impacts climate change. Professor Vikram would be talking about the interconnection between air quality and climate change, which both have common origins and common mitigation strategies. Thanks, Professor Vikram, and welcome aboard. I will now invite Professor Sagnik Dey, CERCA Coordinator and Associate Professor at the Center of Atmospheric Sciences at IIT Delhi, to briefly introduce today's speaker and also invite him for the talk. Professor Sagnik.
So it's a great pleasure to introduce Professor Vikram Singh, today's speaker. Vikram is currently working in the Department of Chemical Engineering at IIT Delhi as an assistant professor. His work focuses on transport problems in colloids, emulsions, and aerosols. His current research interests include understanding air pollution in Delhi, source apportionment using real-time chemical speciation of particulate matter, which is a very novel and new technique. Fundamental studies on understanding the impact of light scattering in emulsions and aerosol suspensions, interfacial science problems for heavy oil, CO2 capture, and utilization. He is a trained chemical engineer with a B.Tech degree from IIT Delhi itself and a Masters and Ph.D. from Cornell University, USA. He worked as a research engineer at ConocoPhillips and Phillips66 and as a postdoctoral fellow in the Department of Seismology, Columbia University. So with this short introduction, it's a great pleasure to invite Professor Vikram Singh for today's talk.
Thanks a lot, Sagnik, for that very kind introduction. And thanks a lot, CERCA, for having me here. It's a great pleasure to be talking on this issue. So let me share my presentation. So I'll be talking about climate change and air pollution, and we'll be looking at some common root causes for both these problems and some mitigation strategies, which are common for, again, both climate change and air pollution. I guess then you haven't seen any of the other slides after my first slide. So I'll quickly go over this introduction. So we have, so this was a cartoon from Economist where the world is fighting the COVID virus, and this beast of climate change is standing outside the ring. It's the preliminary round in which the world is fighting the COVID virus, so it's soon going to meet the climate change beast. I've also written now air pollution on the same beast, and I think this part of the world definitely needs to be prepared for both these. All right, so some introduction on climate change. So you have solar radiations coming from the top, high intensity radiation, low wavelength, high intensity radiations. They hit the ground and then get reflected back. When they are getting reflected back, these radiations are high wavelength radiations, which can get absorbed by CO2 or greenhouse gases in general absorb them. And when they are absorbing them, they are not allowing these radiations to go back to the outer space, and your can over time lead to increase in temperatures or increase in heat, which is stored in the atmosphere. Okay. What are the examples of these greenhouse gases? So CO2 is the predominant example, and then things like methane, black carbon, N2O, ozone, and water. And some of these things, as you know, are also air pollutants. CO2 in general, I would not call it as an air pollutant, essentially because CO2 does not have any harmful health effects, at least at the kind of concentrations that they are present in currently in the atmosphere, something to the tune of few hundred ppm, CO2 does not have any adverse effect. The CO2 numbers in my room where I've been sitting for past few hours are going to be higher than the CO2 numbers in the ambient air. But other than CO2, the other gases are pollutants. So CO2 has been around for forever. Why are we worried about it now? The reason is that your CO2 numbers have been increasing, and they are increasing at a pretty fast rate, as a result of which we are also seeing increase in temperature, increase in global temperatures. What are the sources for CO2? So this is based on the economic sector. You have here I'm showing you the greenhouse gas emissions for these sectors: industry, transportation, buildings, agriculture, electricity and heat, and other energy sources. And as you can see, one can relate, a common man can relate with each of these economic sectors, and we understand how important they are. If you narrow down further on the specific sources in these economic sectors, one can see that 73% of your greenhouse gas emissions are from the energy sector, and then a decent amount from agriculture, forestry, and land use. So whenever you are cutting forests to create agricultural land, you are again in a way adding to the greenhouse gas emission in the atmosphere. And then industry and waste. So energy is the main component here, and let's try to see what are the primary sources of energy that we are using in the world. So as you can see here, more than 70 or more than 80% of our sources of emissions are coming from fossil fuel. So 28% from coal, 34% from oil, 24% from gas. So this makes 86%. So 86% of our energy sources are fossil fuels, hydrocarbons, which when we burn, are going to lead to creation of CO2. And then about 4% is nuclear, 7% is hydrocarbon, and 2% is wind and solar, which one can consider to be a renewable source of energy, not adding to the CO2 balance of Earth's atmosphere. And then biomass, 1%. Biomass does add to CO2, but in a way, if you are able to reforest the source of biomass, then in a way this is also a renewable source of energy, where the CO2 generated can be again reutilized in the production of biomass over a period of few years. Right. So this is the summary of our sources of climate change or sources of greenhouse gases. Now let's look at what are air pollutants and what are the sources of air pollutants. So here are the examples of air pollutants. So things like NOx, SO2, particulate matter. They form air pollutants. Now let's look at the sources of air pollution. So here again, and we'll see that the sources of air pollution and the sources of greenhouse gas generations, they are again there's a lot of overlap among them. So things like vehicular emissions. So you use fossil fuels for vehicles. You also generate a lot of pollutants from vehicles. Power plants, again, you use fossil fuel, generate CO2, and generate a lot of pollutants. Waste burning, biomass burning, industrial emissions, all these add to the air pollutants, adding in the atmosphere. Something like dust is one source of air pollution, which one would not like to directly relate to climate change. And then for air pollution, there are sporadic sources like Diwali fireworks, stubble burning, but these sources are there only for as a function of few days or few weeks at most in a year. So now let's look at the common root causes of both air pollution and greenhouse gas emissions in the atmosphere. So on the left-hand side, I'm showing you the energy sources that we already looked at for greenhouse gases. On the right-hand side, we are looking at the pollution sources in Delhi alone. And if you see closely, a lot of these sources are common. So things like coal, diesel, petrol, biomass burning, industrial sources. These activities are common for both pollution generation in the atmosphere and for greenhouse gas generation in the atmosphere. So let's. So why? One can see that greenhouse gas generation and air pollution generation sources are common. So what's stopping us to get rid of them? Why are we not able to get rid of both these greenhouse gas sources and air pollution sources? And you'll be getting rid of both the problems if we get rid of these common sources. So let's take a step back here and look at the implication. Why do we need these? Why do we need these hydrocarbons? Why do we need these common sources in the society? So sometime back, Amartya Singh and Misbah al-Haq, these guys define this parameter of Human Development Index, which contains things like literacy rate, these three parameters: literacy rate, health, and per capita income, and which are essential to define how. This kind of definition for growth of a country is different from just GDP, which only looks at the economic wealth of the country. So if we look at Human Development Index as a function of CO2, we see the following. So on the y-axis here we have emissions per capita, so tons of CO2 that are being generated per capita of the population, and on the x-axis we have the Human Development Index. So if you look closely, the Human Development Index, which is high for the developed countries, the emissions per capita are also high. So CO2 being generated by these countries is also on the higher side, and your HDI is high for these countries. Whereas countries like India or the developing countries like Brazil, China, Indonesia, Nigeria, Bangladesh, they are on the lower side of this line. HDI numbers are lower. Also the emissions per capita are lower. So in a way, one can see that your emissions, your greenhouse gas emissions are important, or they play an important role in determining the HDI indirectly. So at the end of the day, these developed countries, they are using more fuels, more hydrocarbons, as a result of which the emissions are higher. But as they are using that, their HDI index is also on the higher side. So in a way, if these developing countries, they want to become, they want to climb up the ladder, for them, generation of carbon dioxide or utilization of fuels, that becomes an important entity. So now let's look at, so CO2. One is seeing that CO2 is required for this kind of growth. Fuels are required for this kind of growth, at least in the current situation when we haven't, where renewable sources of energy are still in their infancy. However, so CO2 is one major greenhouse gas. What is the second? Which one is the second biggest player in the climate change story? So black carbon. So black carbon, so CO2 is the biggest player, but the second biggest player here is black carbon. And black carbon, although CO2 is not an air pollutant, black carbon is. And how does black carbon leads to how does black carbon leads to global warming? So black carbon has a high has a refractive index with the imaginary component, as a result of which it absorbs it absorbs solar radiations which are directly falling on top of it. And those radiations then don't end up going to the surface of the earth. So your solar energy, solar power that you could be generating, that lowers down. And of course, those radiations are never they never get reflected back. So black carbon absorbs a lot of heat. Their sources of emissions are heavier hydrocarbons, so things like diesel, coal, kerosene, oil, biomass, and cow and buffalo dung fatties. So which are very commonly used for cooking and heating. So these are different sources of emissions of black carbon or soot particles in the atmosphere. And if you look closely, although CO2 emissions of developed countries like America, Germany, UK are on the higher side. So this here I'm showing you the total CO2 emissions. Of course, if you are going to divide it by the population of these countries, the per capita numbers are going to be even higher than what you are seeing here, and comparing to countries like India and China. So CO2 emissions are higher for these developed countries, but if you look at emissions of things like black carbon, they are higher for countries like China and India. So black carbon adds to both problems like air pollution, climate change, and we can one can think of reducing black carbon without impacting this HDI ladder that we are interested in climbing down the line. Here I'm showing you some of the impacts of reducing black carbon and methane. So as you can see here, reduction of black carbon and methane, and IPCC has listed something to the tune of 400 measures by which one can do that. If you reduce black carbon and methane by following these measures, one would be talking about decrease in atmospheric forcing by 8%, 10.6%, sorry, 8.3 watt per meter square, 10.6 watt per meter square in Bangladesh, 8.3 in India, and similarly in other countries. So your impact on global warming will be reduced if one is able to reduce black carbon and methane. So one of the biggest sources of methane is livestock that we have in abundance in our country. And then there are benefits like health and agriculture, which come from the pollution side of these entities. So if you look carefully, one would be talking about reducing premature mortality by something to the tune of 800,000. So 8 lakh less people would be dying if we reduce black carbon and methane with the specific provisions. Decrease in, so here I was talking about plot C. If you look at plot E, the increase in the production, annual tonnage, crop tonnage, increase in that production will be something to the tune of 775 tons for a country like India, 744 ton for a country like China, 6,000 for United States. So both these and lower plot gives you the percentage. So both these, so things like health benefits, agricultural benefits will be there. At the same time, your climate impact will be lower down by reducing pollutants or greenhouse gases like black carbon and methane. So these are common pollutants. These are pollutants common to both the problems of air pollution and climate change. So now let's look at some impacts of climate change and air pollution. So for climate change, we have problems like extreme heat waves, changing rainfall pattern, decline in monsoon rainfall has been seen for India since 1950. And then there is a frequency, varied frequency of floods and droughts. Both these things, both floods and droughts are impactful. They hurt agriculture. They hurt mankind in general. Then groundwater depletion. So we are already in this state where we are overexploiting groundwater. And that problem is also going to intensify. Glacier melting. So Himalayan glaciers, their rate of melting is increasing, and it's going to intensify with climate change, with increasing temperatures of the atmosphere. Indian rivers, they are going to be seasons in which they are going to be flooded when glacier melting rates are going to be stronger, and they are going to be seasons when they are going to be when the flow rates are going to be on the lower side. About 700 million people in this entire Indo-Gangetic plain, starting from Lahore to Dhaka, Indo-Gangetic and Brahmaputra plain, about 700 people live there. So they all, about 700 million people are dependent on agriculture. So they all will be affected by something like this. Then a problem like sea level rise, again, coastal areas like Bombay, Kolkata, Chennai, Dhaka, again, one of the most populated per unit area, one of the most populated regions in the world. And you can imagine when the population from these regions are going to get displaced, they have only one way to come to us, and that's Delhi or inland in India. Food security is going to be a problem. So less rainfall, or in certain seasons, more rainfall in other seasons. So for example, this monsoon, this heavy rainfall in this monsoon has so far prevented the harvesting of paddy crop. Something that should have started early September, mid-September, hasn't really started at the scale that it should so far. Then energy security, so problems like hydropower, they are going to be affected by it. Water security, increasing demand for water. Then, of course, problems like health due to heat waves and migration, and there's going to be conflict, geopolitical conflict because of this migration. Then let's look at the impact due to air pollution. So something that we experience it on a daily basis. So air pollution has increased the mortality rate. In India, more than 1 million people die from air pollution, premature death due to air pollution. Hospital admissions are on the higher side. There are respiratory symptoms, cardiovascular problems, workday loss. So it's not so air pollution. We typically relate it to health problems, but there is an economic loss also associated with it. So when you are losing work days, you are losing on the economy side also. Then agricultural losses are there. So plant growth depends on things like temperature, solar radiation, water, and nutrients. And atmospheric aerosol plays an important role in that or influence that. Then pollutants like ozone slows down photosynthesis that can it can enter the plant by the stomata and damages the inner cell walls. Again, it hurts agriculture. Then air pollution, now with the growing demand of renewable sources of energy, growing demand of solar power, air pollution or aerosols in the atmosphere also affect solar power generation via light scattering or absorption of light in the atmosphere. And we have seen that something to the tune of 12% radiations are being lost, or 12% solar power is decreased due to air pollution in the atmosphere. So one would typically, when we talk about problems like air pollution or climate change, we seem to be claiming that everyone is going to be impacted by it. We do want everyone to believe that everyone is going to be impacted by it, but we are going to see that we see that this impact is going to be differential. So there's going to be a social inequality in the impact that both climate change and air pollution would be exhibiting, which they are already doing to some extent. So let's look at the social element of both these problems. So here, so we have already looked at how CO2 emissions per capita scale with HDI. Here I'm just showing you the net CO2 emissions per year for countries like USA, China, India over a period of time. As you can see, that emissions from countries like India or developing countries like India is on the much lower side, and it's even lower when you scale it with per capita emissions compared to developed countries like America. However, the impact of climate change that one is projecting or one is already seeing, they are going to be higher in the south or countries which are closer to the equator. So most of these developed countries in Europe, in US, or even Asia, a country like Russia, they are in the north. The impact of climate change is not going to be as bad as the impact that countries like India or countries in the south, countries like Brazil, India, most of Africa are going to see. So although the emissions are higher by the developed nations, the impacts are going to be higher for these developing nations. And even in these, even for these developing nations, one would, one needs to realize that it's the emissions. So here we are looking at emissions as a function of population, and the world. We have divided the world in 4 categories here. So America, China, OECD minus America, and non-OECD minus China. So OECD countries mostly. So there are about 37 countries here. And mostly European countries and developed countries are part of it. So as you can see that, so on the x-axis, we are looking at cumulative population. So as you can see here that emissions from the top 200 million people, even in these developing countries, so non-OECD minus China are the developing countries, India is part of that. So the emissions in this top 50 to 100 million population are matching with the developed world. So there's not much difference here. Himanji, can you see my mouse moving?
Yes, I can see.
Okay, all right. So the emissions from this top 50 million to 100 million people, even in this developing part of the world, they are matching what we are seeing for the developed part, for China, for America. They're almost of the same order. So emissions from this segment of the population in India or from these from the developing nations are higher or are of the same tune as the developed nations. However, the impact again, when we look at impact, so impact on, for example, agriculture. So farmers are going to be most impacted by it, which and they don't belong to this top 100 million people that we are talking about. So the class of the society which is going to be most impacted by it is not emitting as much CO2 as the class of the society which is going to be least impacted by it. And then, so this was the social inequality that climate change is introducing. Then there is also social inequality with air pollution. So I mean, people like us who are sitting in offices and working all day, our exposure to air pollution is nothing compared to people on the road spending more time in the vehicles there. or spending more time on the road on a daily basis. And the worst amongst us are these women here using biomass, using wood, using cow dung patties, buffalo dung patties, and the main reason they are being exposed to these high concentrations of effluents is, one, they are poor, second, they are women. If I can quote Kirk Smith here, a woman using biomass in traditional chula is smoking or is inhaling pollutants equivalent to 300 smokes a day, so 300 cigarettes a day. The kind of air pollution that she's been exposed to. All right, now let's look at the mitigation strategies here. So and as we see that the root cause is common for both air pollution and climate change, the mitigation strategies are also at some level common for both these problems. So one can, I mean, one obvious thing to go for is reduce our, we need to reduce our energy demand, reduce our electricity bill to begin with, reduce our petrol, diesel bill on a daily basis. Less dairy, less chicken, less meat. So these sources of food are second in the food chain, going back to green, going back to vegetables is less their cost on climate is on the lower side. As I mentioned, that the livestock is one of the major sources for methane in the atmosphere. And drive less, fly less, again, less use of fuel. We have to generate less waste, cut on our consumption, clean fuel. So moving from fuel like biomass to clean fuel would help in both reducing the air pollution and reducing the CO2 emission per unit of energy that we are generating. And then, of course, switching to cleaner power generation techniques, so things like solar power, wind power, that will definitely help us in mitigating both the problems of climate change and air pollution. And most importantly, I think we need to start talking about it. In India, or at least in the NCR region, we have started talking about the problem of air pollution, but I think we need to take we need to start taking climate change also seriously. When this problem is going to get bigger, it's going to be hurting countries like India the most. And I think we need to now take a stand on it, and we need to start talking about it. It's still not governing the climate change policies, still not popular. We are still not talking about it at large. So I think we need to take a stand on it now. So let me end this talk by a crazy idea of solar geoengineering. So I had to spend a lot of time thinking of how to end this relatively depressing talk. It's typically pretty challenging to end these talks on climate change and air pollution in general. So there's this one strategy, there's this crazy strategy that people have been, that scientists have been working for quite some time now. The strategy of solar geoengineering. This is really about introducing pollutants in the stratosphere, the upper atmosphere, and reducing the climate problems that we are facing. So I'm quoting here Arrhenius. There is a small good mixed with evil here. So he made this statement about 100 years ago when he was quantifying global warming due to increase in CO2 numbers. And this is early 20th century. So they were able to see the change in global temperature compared to pre-industrial stage by looking at the increase in CO2 numbers. And he felt, Arrhenius felt that although, yeah, it's a bad phenomena that due to these anthropogenic activities, global warming is taking place. However, he felt that there is a small good, there might be a small good also involved with this problem of global warming. And those were the days when people were also concerned about, people were studying ice age on Earth, and people knew that when ice age, in the past, when ice age has arrived, it annihilates any form of life on Earth. So he felt that this problem of global warming might delay the problem of ice age. This strategy of solar geoengineering, with this strategy of solar geoengineering, I am saying that this problem of air pollution may also have a small good involved in it. So this solution was actually motivated and at some level tested by this volcanic eruption in 1991 in Philippines, where your particulate matter was, since this eruption was of high energy, particulate matter was introduced in the stratosphere. So in general, when we talk about air pollution, we are talking about the lowest layers of atmosphere, the boundary layer inside troposphere, so something to the tune of 100, 200, 1 kilometer kind of heights. Stratosphere is at a height of 50 to 100 kilometers. So in this explosion, when these particulate matters were introduced in the stratosphere, people saw that, or scientists saw that for a period of about 15 months, the temperature of the Earth actually lowered by about 1 Fahrenheit. So these, so here the first plot and the first figure that you see on the upper left. Here you have the pre-explosion time, and we are just looking at AOD in the stratosphere. So AOD, full form of AOD is aerosol optical depth. The larger the numbers are for AOD, the higher are the pollutants in that region. So in this, so stratosphere was completely clean. So we are talking about something to the tune of 10⁻³ here. If you look at lower legend here, so something to the tune of 10⁻³. And as and right after the explosion, which took place in June 1991, the numbers, the AOD numbers started increasing, and they reached something to the tune of 10⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻ increased by a factor of 100 during this period of June 1991 to December 1993. And during this period, it was observed that the temperature of Earth was lowered by about 1 degree Fahrenheit post-explosion. But I mean, guys, we need to realize here that while this is just one effect, introducing aerosols in the atmosphere, all these aerosols at the end of the day, they are going to deposit on the surface of the Earth. They are going to be part of of the air that we are breathing. And there are going to be a number of side effects that one needs to worry about, or one needs to consider when even thinking about actively adding aerosols in the stratosphere. So things like ozone, the reaction of these aerosol particles with the ozone, and the ozone in the stratosphere is the good ozone. That's the ozone which prevents UV radiations from coming to the surface of Earth. There are a lot of these side effects then that one needs to be worried about. And then here I'm showing you the economic impacts of both solar geoengineering and global warming. So these are again very preliminary models which have been used for projecting GDP over time. And here we are looking at projected GDP in 2100. So the first figure on upper left that we are seeing, figure 8. Here we are looking at GDP the change in GDP in 2100, when no action is taken and global warming in the present scenario takes place. So as you can see that countries like India, countries closer to the equator are going to be the most impacted by this scenario. Whereas countries like on close to the pole, countries like Russia, Europe, Canada, there, at least from the GDP perspective, things may not be that bad. On the other hand, if you think of the possibility of cooling the Earth using something like solar geoengineering, one can imagine the inverse taking place for countries like India. So I'm just showing you this figure to make you realize and to make us realize that playing with the environment could be, I mean, one is its effect is not going to be uniform throughout. It's not going to be good for everyone, or it's not going to be bad for everyone. There could be possibilities like this, which can lead to increase in conflict. All right, so with that, I would like to end and thank a number of collaborators, a number of students who have been working on the problem of air pollution. I haven't talked about some of the work that we have been working on air pollution, so something that Singh mentioned. So in the lab, we are working on real-time source apportionment. We are carrying out source apportionment studies to study using real-time chemical speciation of aerosol particles in the atmosphere, impact of aerosol particles on solar power, impact of these specific aerosol particles like chloride, or looking at the sources of these specific aerosol particles like chlorides, which are in the current atmosphere, are seen in numbers never seen in any other developed or developing part of the world. So I would like to thank a number of my collaborators here at IIT and the students who have been working in the lab, and all these funding agencies which have been funding the research activities in the lab. All right, with that, Singh, I would give the platform to you, and we can have a discussion or question and answers if you would like.
Yeah, thanks, Vikram. So yeah, I mean, it's now Q&A time. A few questions already in the chat box. So I will just read and.
So yeah, I can see. Yeah, you can read.
Yeah. So yeah. Let me read. So there is a question on black carbon. So black carbon content is probably lesser from diesel motor. I assume it may be better for climate change, but is it not? Is it right that air pollution is worse off by PM2.5 emissions of diesel motors?
Yeah, can you please repeat, Singh? I missed out, or let me also open.
Oh, sorry. Yeah. So the question is, black carbon content is probably lesser from diesel motor. I assume it may be for climate change, but is it right that air pollution is worse off by PM2.5 emissions of diesel motors?
So what's this last statement, Singh? Air pollution is worse off?
So basically, I think he wants to know that if there is large contribution of PM2.5 emissions of diesel motors.
There's large contribution of PM2.5 emissions
from diesel vehicles, basically, if I understand the question correctly. So what is the? They're saying that black carbon emission from diesel vehicles is not very high. So for climate change perspective, that may be better, but may not be that good for air pollution perspective, the diesel vehicles.
Yeah, so definitely. So now with BS6 coming into picture, I would imagine that black carbon emissions from diesel engines are going to be on the lower side, and in theory, completely eliminated if implemented well. And one interesting thing, I know we all put down for diesel vehicles a lot. One thing to note here is that diesel the CO2 emissions from diesel vehicle is actually on the lower side. Per kilometer that your vehicle is traveling, the CO2 emissions from the diesel vehicles is on the lower side. And this is something that I actually wanted to discuss also in this talk, but because of time, I couldn't go over it in details. In Europe, actually, in the 90s, early 2000s, there was a boom in diesel engine vehicles, and the main reason for that was the government was pushing that idea that diesel vehicles, because the efficiency of diesel vehicle is higher. So anyone who has driven a diesel vehicle would know that your per liter mileage of vehicle increases with diesel engine. So if one can get rid of the air pollution problem there for diesel engines, on the climate side, it's not that big. The CO2 emission actually reduce with diesel engine because of their higher efficiency.
Okay, thanks for that. I can't see any more questions in the chat box. I will take liberty actually of asking one. So there are now a couple of studies out which have shown, particularly last year, published that if you reduce air pollution globally, which actually we are trying to do to protect our health, because these are mostly scattering aerosols. As a kickback, your temperature is going to increase. So how do you maintain that balance? What's your view on that?
Yeah, I mean, starting in the short run, yes, that is, I mean, we are going to have that effect. In the short run, these aerosol particles, which are, I mean, which have been scattering light, their numbers are going to come down, and as a result, in the short run, yes, the temperatures are going to be on the higher side. But if you look at the net benefit, net effect of reduction, I mean, we would, for this kind of reduction, we will have to move to renewable sources of energy. We'll have to move to better efficiency of our fuel of our engines. So again, these two problems are very much interconnected. Lowering of air pollution, one might feel that since air pollutants, so again, for the audience, a lot of our air pollutants, so things like sulfate, nitrates, all these inorganic air pollutants, they actually reflect back our solar radiations. So in theory, once we remove them from the atmosphere, one would imagine that it's going to increase the temperature. So yes, that is going to happen. But when in the process of removing, so I think one is we will have to move to these renewable sources of energy, which anyway are going to reduce CO2 emissions. I don't think we should debate on better health for people over the possibility of changes in increase in temperature.
Yeah.
The main source is CO2. We do need to reduce emissions.
Exactly. Yeah, I mean, we also argued it that way. It's always a good trade-off. So there is a question. It asks your view about emission from the solid fuel burning in households and waste burning, because you talked extensively on transport and others. What about these two other sources, which are also quite important?
So solid waste and what's the second?
And basically domestic, use of solid fuel.
So use of things like wood and cow dung patties. So there also there is a bit of disagreement between air pollution and climate change. So climate change, again, one good thing about the solid fuel like wood, as long as one is using wood, waste wood, which is currently not growing anymore, and most of these cooking activities actually involve that. So as long as waste wood is used, one can consider it as green carbon too, because the time cycle over which your wood grows is something to the tune of few years, and then one can use it. Your plants or trees grows is something to the tune of few years, and one can use it for burning activities and then again regenerate, and during this time can regenerate. So as long as we are not deforesting our system. So something like, I don't know if, I'm sure there are a lot of people here from IIT. So you would see that at IIT, every other day, there's an entire truck which is full of bio-waste, this plant waste or tree waste that we pick almost on a daily, every other day, every week. So that that kind of waste, if one is utilizing for as a fuel, and since it's regenerating itself, we are not deforesting IIT for this kind of fuel. So as long as it's used in this this pattern, it's not hurting the climate. However, as I showed you, the woman who's using this biomass for cooking in this conventional chula, the kind of emissions that she's been exposed to, it's tremendous, and we really can't. I mean, we should not even think about promoting something like that. The kind of health effects that direct usage of this kind of biomass in those conditions can lead to are tremendous. So yeah, I mean, I would, again, from the health perspective of this person, I would not go for use of biomass or solid waste. However, if it's being done under conditions where you are where the pollution effluents are being mitigated and they are being regulated, which countries in Europe have been doing now. They have started doing it. So as long as there's no deforestation, as long as the pollution, your effluents are well regulated, I would go for that. It will again benefit the climate change strategy.
Yeah, thanks. So we'll take the last question, which is here. So I will read the question, Vikram. Will the bioculture increase climate heating as they eliminate usage of inorganic products and also increase agricultural surface?
Can you please repeat, Sagnik, again?
You can see the chat box.
Yeah,
so
I can see it. Will the bioculture increase climate heating as they eliminate usage of inorganic products and also increase agricultural surface? Yeah, I mean,
yep.
So deforestation is a problem. The 12% that of emissions, greenhouse gas emissions that I was showing in that plot, that was a major component of that was that with growing population, we have been deforesting, and for usage of biofuels like wood, we are for burning activity, again deforesting, and that has serious implications to the climate change problem. So yeah, it's going to be problematic.
Okay, I think we're running out of time, so let's end today. On the behalf of CERCA, I want to thanks again, Professor, taken time for the fantastic talk. I also want to thank the audience for showing interest. Every month we announce this seminar. We get so many participation, which is really heartening to see that people are concerned about this kind of real problems, air pollution and climate and all. Keep our CERCA website. We will very soon announce our next seminar, and then I hope that you all will be able to join our next seminar too. So with that, let us end today's session. Thank you all. Stay safe. Bye bye.